Hi world, I'm Peter.
This is Peter. He builds these and has a CNC machine. This is Aleksandar. He works with Peter and is pretty good with wood. I worked with them last year on a nice project documenting a full month of construction work. And during that period, I couldn't stop thinking about my 3D printed lens rehousings and how they would turn out if they were made out of proper materials like wood or even metal. Deep down in my gut, I knew what must be done. CNC time it is. But which one? The sexiest choice was obviously Makera Z1. It looks ideal, it's even smaller than my 3D printer. So I paid the deposit even before Kickstarter went live. But life tends to give you a lot of lemons.
I'm gonna get my engineers to invent a combustible lemon that burns your house down!
And as soon as Kickstarter went live, I went in to back the project and get my own unit. They were not shipping to my country. I contacted them, they instantly offered to refund my deposit, but that was about it. And sadly for me, I had to keep looking. Of course, then I went on a binge search for alternatives, went through a lot of brands, Genmitsu, Lunyee, Svanfon, and was no closer to a solution. They all offered seemingly awesome, cheap desktop CNC solutions, and all of them claimed they could cut metal with no problem. During my frenzied search, I stumbled upon this majestic magic man. 日本語がわからないなら AI 音声を使ってください。He took a very cheap Lunye 3018 Ultra, did a lot of upgrades on it until it was more than able to cut aluminum, without any significant frame resonance. Oddly enough, it was just at this time Lunyee was about to release 3020 Nova, which was basically this guy's version of 3018. Linear rails, ball screws, stiff frame, pre-built, 800 watt spindle, absolutely top-notch specs, at least for a $500 CNC machine. Shipping was very fast, but of course I had to wage war with DHL and my country's customs, and after a couple of weeks of back and forth, I finally got it. Yes. CNC comes pre-built, you only need to screw a couple of screws, and it comes without this box. But trust me, you need the box. Remember him? Yeah, you do. He built this box for me. I had some crude drawings and provided the most generic pyramid acoustic panels, and I'm extremely satisfied with the results. I did some very basic measurements, but they are more than enough to see the difference. So in order to keep this process from being overwhelming, we're gonna make a nice list. First, we're gonna take measurements, then we'll move on to CAD modeling. After that, of course, comes CAM programming. Then we're gonna download and install UGS, which is a universal G-code sender. Afterwards, we're gonna install the drivers and home and zero our machine, including Z-probing as well. We're gonna learn how to fasten our stock properly, oversee the machining process, because you can't really just leave it alone like with 3D printing. And we're gonna swap tool bits accordingly. I know, this seems insane and far more work than with 3D printing, but I'm telling you, it's worth it. You get these. Okay, I know that one failed, but I promise it gets better. So, now we are going to go through my list step by step, and you're gonna see what I see. And it will be quite broad. It will be very simple. I will make it so simple. I will make it so simple, even the ducks will be able to do CNC milling, trust me. So before starting the list, we need to choose the project. I first wanted to redo one of my previous works, but then I saw this Volna 80mm f2.8 with a PL mount adapter. I never actually made a video about it. It works well, but due to the print color, it has all kinds of light leaks and color shifts. So we're gonna use this as our guinea pig. And just so you know, I'm gonna be using wood, so I'll start making metal parts once I'm confident in my own skills. As we all know, modeling starts in the real world. You have to measure the thing, draw a shitty sketch, which is a mandatory step, check, measure, repeat, and do that 5 times again. Since the flange distance for Kiev 88 Salute is around 82 millimeters. This is the height we'll be using for the adapter. I'll simply reuse the sketch for PL mount lattice I made a while back. Add a simple cylinder, add 3 screw holes, and that's pretty much it. For CAD modeling, I use FreeCAD and SolidWorks, but recently I've been using FreeCAD more because I have some qualms with SolidWorks that I'm not gonna talk about right now. But for CAM, I use 1.2 FreeCAD weekly build. Why? Because SolidWorks has a fatal flaw. Believe it or not, it doesn't support GRBL G-code export. And my CNC and most of the affordable desktop CNCs use this, Gerbil. There are workarounds, but no man, I just don't want to deal with this. Now we move on to CAM programming. This part is a bit more clunky than modeling itself, but once you get the hang of it, it's nice and quick. Set up a job, then designate the tool bits you'll be using. I'll be using 6.35 and 2mm bits. They are both flat end mills. Let's add them here. Then we pick a feature, pick an operation, like so. And of course don't forget to set feed rates. 300 to 400mm, you can check out the reference on Google. For softwood it doesn't really matter that much. After finishing the CAM for all features and making all toolpaths, we export the GRBL and go over to UGS. You can look at this as an interface between your PC and CNC machine. First off, we gotta install the drivers. They came with the machine. Plug in the USB, pick the COM port, connect, and yay, it works. In case you don't hear the sound when you plug in your machine, check if the emergency button is pressed down, since it cuts power to the CNC. Mine was pressed down because I played with it before I connected CNC to my laptop. Sadly, I spent 30 minutes downloading all kinds of drivers and troubleshooting with different USB ports and cables. After we are done with this, we load the file, and this is where you'll probably have problems as well. You'll often find yourself with this machine technically wants to mill above the stock. This plane represents the stock surface, so we gotta go down. This means that your origin point is not correct. Go back into FreeCAD, job settings, pick origin point, export again, load it up in UGS, and it should look like this. Before machining, we need to zero the machine. For example, let's jog the spindle over here, click Reset Zero, and move around to get a sense of where the machining will take place. This is essential because very easily you can end up milling out of your stock surface. Your axis might be inverted. It's goofy, I know, but not that difficult to resolve. In case your axes are inverted, you can do this. Changing these values just flips the movement on the chosen axis. I'm not gatekeeping any knowledge. You can just Google commands without knowing any coding, enter the new values, check the X, Y, and Z axis to see if you flip them correctly. Now we should be ready. Return to zero, turn on the spindle, and let's begin. During the milling process, we just gotta oversee the machine to check if the stock is slipping, if the feed rates are nice, to keep listening for any odd sounds, and to be ready to stop it if things turn to chaos. Yes, I set it on fire. I could feign authority and knowledge, but in reality,
I'm kind of retarded.
I was wrong. My feed rates were too slow. You should use 800 to 1000 millimeters, unless you're trying to start a campfire. After all operations for the first tool bit finish, I need to do a tool change manually, of course. So we take these 2 wrenches, out it goes, put in the smaller bit. You have to tighten it really good. And we can resume our process. Here we come across another issue. Due to the 3-axis nature of our CNC machine, it seems like our model can't be milled in one go. We did this side, so we need to flip it and do the other side. This is called two-sided machining, milling, whatever. And it's not forgiving at all. It is mostly solved with these holes and dowels. I cut the centering holes in the stock, so when I flip it, it remains centered. And for dowels, I'm using my 3D print. Okay, I use it sometimes. Most of the time I just set the 0 at the center of one of the dowel holes, which are symmetrical, manually align the spindle with the dowel hole, and just start the operation. Snap! There goes this piece, straight into the dumpster. Here I took the only piece of material I had left, an MDF board. Practically speaking, it'll be useless for load bearing, but the point here is practice, precision, and the product. It's done. And voila! Pull out the stock. We need to do a bit of sanding to smooth out these rough edges, but look at that. It is majestic. Ferocious. This here is the reality of the process. A ton of mistakes, wasted material, centering issues, loose stocks, and more. So, what's the verdict? Even though I haven't machined any metal parts, I've actually test cut some metal, and this CNC is a monster for its price bracket. If you are patient, meticulous, and do your homework, it will serve you well, I'm sure. Now, there must be some downsides. Nothing in life is perfect, isn't it?
You are correct, my dear boy. There always need be some problems.
With my CNC, I bought this vise. It's nice, it holds the stock well, it's very sturdy, but along with it you get T-nuts, which are oddly enough not compatible with the aluminum profile of the CNC machine. This wouldn't be a problem if it was clearly stated on the website, but they recommended this vise when I was picking out my CNC machine. So this is rather easy to remedy. Go on AliExpress, click a couple of ads, get 1 million of these for $5, but I really dislike the experience of having to jerry-rig everything. I've contacted the support and they've offered to send these extra T-nuts for free. Kudos to them, but if it would have been very nice just getting them right off the bat in the first place. I know this all looks troublesome and exhausting, but trust me, it gets really easy once you get going. And as you keep going, problems don't seem as problematic anymore. Emotionally speaking, you grow accustomed to the trials and tribulations of life, and you keep growing with each step you take forward, until you eventually become the CNC milling monster.